Buckle up, everybody, because this deep dive is, well, it's going to take us down
So yeah,
a rabbit hole of time travel.
it's a deep one.
We got a stack of sources here.
Oh yeah.
We got, like, excerpts from a physics book, an essay that's, like, straight out of Doctor Who,
It really is.
a patent application that seems like total science fiction,
Yeah, it's a wild one.
and a chapter on consciousness that might just redefine reality as we know it.
Oh yeah, for sure.
And so,
Big questions.
big questions. Our mission is to find out if time travel is just a fantasy
Okay.
or like a potential future reality.
Right, and what I think is so cool about these sources is that they
Yeah.
tackle this question from like all these different angles.
Yeah.
We've got like hard science, theoretical physics,
Yeah.
practical engineering.
Yeah.
We even get into like the mysteries of consciousness.
Yeah. And you know, I gotta say, when I saw like patent application and time travel in the same sentence,
I know, right?
my eyebrows definitely like shot up.
Yeah.
But we're gonna break it all down. Don't
Okay.
worry.
Step by step.
Okay. So let's start with this physics book.
Right.
This thing, it throws out a wild new idea about gravity
Yeah, it really does.
that like challenges everything we thought we knew.
Yeah, it really flips the script on how we usually think about gravity.
Okay.
You know how we think about it like as this force that pulls objects together.
Yeah, like the Earth pulling us down.
Right, exactly, like good old Newtonian physics.
Right.
But this source is like, hold on a second. What if gravity is actually a push?
A push.
Yeah,
Okay, now you've got my attention.
right.
How does that even work? I mean, I can definitely feel the Earth pulling me down.
I know, I hear you. It's a wild concept.
Yeah.
But this text introduces like two key ideas to explain it.
Okay.
So first, there's this thing called the subtle magnetic field, or like the SMF.
SMF.
Yeah, and it's like this deeper, more fundamental magnetic field that like permeates the whole universe.
Yeah.
And then you've got the relative vacuum of space, or the RVS. And
Yeah.
basically it's like the inherent pressure
Yeah, okay.
of the vacuum of space itself.
So is this where like dark matter comes into play?
Not quite.
Okay.
Think of it this way. The SMF and the RVS, they kind of work together like this cosmic dance.
All right.
So where the SMF is strong,
Yeah.
the vacuum pressure is weaker.
Oh, okay.
And it's this difference in pressure
Yeah.
that creates the effect that we experience as gravity.
So instead of mass attracting mass,
Right.
it's more like we're being pushed together by this vacuum pressure.
You got it.
Okay.
It's a whole new way of thinking about like one of the fundamental forces of the universe.
Yeah.
It's like imagine a balloon being squeezed inward
Okay.
by the air pressure all around it.
Yeah.
That's kind of how this push-based gravity works.
Okay. I'm starting to get the picture here.
Yeah.
But how does a push-based universe
Right.
lead to time travel?
Okay, so that's where
That's a big leap.
things get really mind-bending. So to understand the connection, we need to bring in another source,
Okay.
this essay that builds on the push-based gravity model.
Okay.
And it introduces this concept of an infinite fractal universe.
Hold on, fractal universe.
I know, right?
Things are about to get trippy.
Seriously trippy.
All right.
So basically, it proposes that the universe isn't just vast.
Yeah.
It's like infinitely vast.
Yeah.
And it's structured in these like repeating patterns on every scale,
Okay.
you know, from the tiniest particles to the largest cosmic structures.
Okay.
Think about like a snowflake.
Right.
The shape repeats over and over again
Right.
at smaller and smaller scales.
Yeah.
That's the basic idea of a fractal universe.
So are we talking about like infinite copies of ourselves
Oh.
living out slightly different lives in like parallel universes?
That's a common misunderstanding about fractal universes.
Okay.
It's not so much about parallel universes,
Okay.
but about different scales.
Okay.
You get the different points in time.
Oh.
Yeah, so the essay suggests that like each iteration of the fractal,
Yeah.
each scale is like a snapshot in time. And moving through these snapshots
Yeah.
is what creates the flow of time as we experience it.
Okay, I think I'm following so far. So
Yeah.
we've got this infinite fractal universe,
Right.
and each layer of the fractal is like a snapshot of a different point in time.
Exactly.
But how do we actually move between these snapshots?
Right, yeah.
That's the million-dollar question when it comes to time travel.
Yeah, totally.
Yeah.
And that's where this essay introduces something called Fibonacci scaling.
Fibonacci scaling.
Yeah, it's presented as like a way to control the SMF and the RVS
Right.
with incredible precision,
Oh.
like a cosmic fine-tuning knob.
So wait a minute. Are you saying that by tweaking this SMF,
Yeah.
we could actually jump to different points in time?
Yeah, the implications.
Like having a universal remote control for time itself.
It's a wild one.
Yeah.
So the essay argues that by manipulating the SMF at specific fractal scales,
Yeah.
we could theoretically create a closed time-like curve,
A closed time-like curve.
or a CTC.
A CTC. What's that?
Essentially, it's like a loop in time,
Okay.
a pathway that could potentially allow us to travel to the past or the future.
Okay.
And that's where things go from theoretical physics to a potential blueprint for a time machine.
You're talking about that patent application.
Yeah,
This is where my mind officially goes into overdrive.
I know.
A patent for a time machine. Really?
Yeah, it's important to remember that this is still in the realm of theoretical physics.
Right.
But what makes this patent so fascinating
Yeah.
is that the technology it describes,
Yeah.
while it's super advanced,
Okay.
it's actually grounded in the same SMF and RVS principles we've been talking about.
I've glanced through this patent, and let me tell you, it gets pretty technical.
Oh, yeah.
There's talk of exotic field generators.
Right.
Metamaterial waveguides.
Yeah.
And something called a chronoloop stabilizer.
It's a mouthful.
Sounds like something straight out of Star Trek.
I know, right?
Right. Yeah.
Yeah, so these are all like theoretical technologies
Yeah.
that, according to the patent, would allow us to manipulate the SMF
Right.
and create those stable time loops,
Right.
these CTCs.
And here's where it gets really interesting.
Yeah.
The patent even addresses the potential for paradoxes.
Oh, yeah, for sure.
You mean like going back in time and accidentally preventing your own birth?
Right.
The classic grandfather paradox.
That classic, exactly.
Yeah.
The patent even outlines this theoretical paradox index,
Yeah.
a way to measure the risk of creating a paradox
Right.
by traveling to a specific point in time.
Whoa.
It's like the inventor is not just thinking about how to build a time machine,
Right.
but also like the ethical implications
Wow.
and the potential consequences of time travel.
So let me get this straight. We've done from rethinking gravity
Yeah.
to exploring this mind-bending fractal universe to a patent for a time machine that, while still theoretical,
Yeah.
is actually rooted in some pretty intense physics and
It's
math.
pretty intense.
Yeah.
Yeah. And what's even more fascinating is how these sources,
Right.
while they're coming from such different perspectives,
Yeah.
they all seem to converge on this idea of time as something much more fluid
Right.
and malleable than we traditionally thought.
It's definitely a lot to process, but we're not done yet. We
Finally.
still have that chapter on consciousness and time to explore.
Oh, yeah.
And I have a feeling it's going to take us even deeper down this rabbit hole.
Oh, yeah. Buckle up. Let's do it.
All right. Bring on the mind-blowing.
I like it.
Let's see how this new perspective on consciousness fits into the puzzle of time travel.
Okay.
All right.
Let's go.
Okay, so we've got this patent that lays out this theoretical blueprint for a time machine.
Yeah.
But it also raises some pretty big questions
Yeah.
about what happens if we actually figure out how to build this thing.
That's where things get really interesting.
Right.
Potentially a little bit scary. One of the first things we have to consider is the concept of causality.
Right.
If we can change the past, what kind of ripple effects would that have
Yeah.
on the present and the future?
Yeah, like that classic grandfather paradox. You go back in time, you accidentally kill your grandfather before your parent is born.
Exactly.
Do you just blink out of existence?
That paradox and others like it,
Yeah.
they really highlight the potential dangers
Yeah.
of tampering with the past.
Right.
It raises questions about free will versus determinism.
Right.
If our actions in the present are already predetermined
Yeah.
by events in the past, do we really have any freedom to choose?
That's a pretty heavy thought.
Yeah.
It's what's the point of making any decisions if it's all already set in stone?
Right.
But let's say, for argument's sake, that we could change the past.
Yeah.
Who gets to decide what changes are okay?
That's a huge ethical dilemma.
Right.
Should we try to right historical wrongs,
Right.
prevent tragedies,
Yeah.
or even alter the course of major events?
Yeah.
And who would be the ultimate judge
Yeah,
of what's a worthy intervention?
I can already imagine the debates
Oh, yeah.
and controversies that would erupt if we had that kind of power.
Absolutely.
It's like opening Pandora's box.
Yeah, it's a slippery slope.
But even beyond the ethical questions, wouldn't any change to the past,
Yeah.
no matter how well-intentioned, have a whole cascade of unintended consequences?
Absolutely. It's the butterfly effect on a cosmic scale.
Right.
Even a tiny change to the past could have massive ripple effects
Right.
that we couldn't possibly predict or control.
So is time travel something we should just avoid altogether, even if we figure out how to do it?
I wouldn't say we should rule it out entirely,
Okay.
but we absolutely have to approach it with extreme caution.
Right.
We need to have those deep philosophical and ethical conversations
Yeah.
before we even think about taking that leap.
It's mind-boggling to even think about.
It is.
Every answer seems to lead to a dozen more questions.
Yeah.
It's like we're peering into the abyss of the unknown.
That's the beauty of exploring these big ideas.
Yeah.
It pushes us to confront the limits of our understanding and to
Right.
question our assumptions
Yeah.
about the nature of reality itself.
Speaking of questioning assumptions, let's bring that chapter on consciousness back into the mix.
Okay.
It mentioned that the divine is omnipresent throughout all timelines.
Right.
How does that fit into the whole time travel equation?
That's a fascinating question.
Yeah.
If the divine is present in every moment of time, past, present, and future,
Yeah.
does that mean there are limits to what we can change?
Right.
Even with time travel.
Are you saying there's some kind of like cosmic safeguard in place, preventing us from messing things up too badly,
Yeah.
even if we tried to travel through time and change the past?
The chapter doesn't explicitly say that,
Okay.
but it does make you think about the interplay between free will,
Yeah.
determinism,
Yeah.
and divine providence.
Right.
It's like there's this grand cosmic dance going on,
Yeah.
and we're just beginning to understand the steps.
It's like trying to solve a puzzle where the pieces keep changing shape as you look at them.
Right, exactly.
But let's shift gears for a second.
Okay.
Putting aside all the risks and paradoxes,
Yeah,
are there any potential benefits to time travel
sure.
that might actually outweigh the dangers?
The potential benefits are immense.
Okay.
Imagine being able to witness historical events firsthand,
Right?
to learn from the past in a way that's impossible now.
Yeah.
Or what if we could travel to the future
Right.
and see how our choices today shape the destiny of humanity?
It's like something out of Back to the Future,
Right.
but I can see how those possibilities would be incredibly tempting.
Yeah, and think about the potential for scientific discovery.
Oh, yeah.
We could study the evolution of the universe,
Right.
observe the formation of stars and galaxies,
Yeah.
maybe even witness the Big Bang itself.
It would revolutionize our understanding of the universe,
Completely.
but let's be real, we also have to talk about the potential for abuse.
Of course.
What if time travel technology falls into the wrong hands?
That's a valid concern.
Yeah.
Any powerful technology can be used for good or for evil.
Right.
We've already seen how advancements in AI are raising a whole host of ethical questions.
Right.
Imagine the chaos if someone weaponized time travel.
Yeah, the possibilities are both exhilarating and terrifying.
Yeah.
You could rewrite history, erase events, or manipulate things for personal gain.
Absolutely.
Knowing the future could give you a huge advantage over others,
For sure.
or you could exploit that knowledge in all sorts of ways.
Right.
It's a lot of responsibility to handle.
It is a lot of responsibility.
Yeah. So we've covered a lot of ground here. The science of time travel,
Yeah.
the mind-bending concept of a fractal universe,
Well,
the philosophical and ethical dilemmas,
Yeah.
and the potential risks and rewards.
it's a lot to unpack.
Where do we go from here?
I think the next step is to dive back into those source materials
Oh,
and see if we can unearth any more clues or insights
right.
that might help us unravel the true nature of time
Yeah.
and our place within it.
All right, let's do it. I have a feeling we're just scratching the surface of this time travel enigma.
Yeah, I think so too.
There's a whole universe of possibilities waiting to be explored.
Let's see if these sources offer any more hints about how we might be able to navigate the uncharted waters of time
Right.
safely and responsibly.
I'm ready for another dose of mind-blowing revelations.
Okay.
Lead the way. All right, so we've talked about like the theory behind time travel.
Right.
And we even got a glimpse at like a potential blueprint for
Yeah.
a time machine. But one thing that keeps coming up
Yeah.
is this idea of like negative vacuum
Right.
or super intense vacuum.
Yeah.
It sounds kind of like a science fiction term.
It does.
Is that just like a fancy way of saying there's less space?
It's a bit more complex than that.
Okay.
Remember how we've been talking about gravity as a push,
Right.
where the vacuum of space is actually exerting pressure?
Right.
This patent suggests that by manipulating the subtle magnetic field,
Okay.
we can create zones where that vacuum pressure becomes incredibly low,
Okay.
even negative.
So instead of actually shrinking space,
Right.
it's more about like tweaking the pressure dynamics
Exactly.
to the vacuum itself.
Precisely. And the patent claims that these regions of negative or superintense vacuum
Okay.
are essential for creating those closed, time-like curves,
Right.
the CTCs, that could potentially allow for time travel.
That's where I gotta admit my brain starts to hurt a little.
I know it's a lot.
Negative vacuum.
But
How do you even measure something like that?
that's a question that the patent doesn't fully answer.
Okay.
It mentions measuring shifts in electromagnetic resonance
Okay.
as a way to indirectly gauge these vacuum pressure changes.
Okay.
But the specifics of like how you'd actually create and stabilize those negative vacuum zones are still pretty vague.
So it sounds like we're still a long way from building time machines in our basements.
Definitely.
Yeah.
There's a lot more theoretical groundwork to be laid.
Right.
But even at this theoretical level,
Yeah.
I think there's a profound shift in thinking here.
Okay.
If we accept this idea of push-based gravity,
Yeah.
then manipulating vacuum pressure to create time loops starts to seem,
Okay.
well, a little less outlandish.
Yeah, I see what you mean. It's like we've turned our whole understanding of the universe upside down.
Right.
Gravity's a push, not a pull.
Right.
Time is a journey through fractal scales.
Yeah.
And even the vacuum of space
Yeah.
isn't just emptiness.
Right.
It's like this dynamic force
Exactly.
gravity might be able to harness.
That's a great way to put it.
So could time travel actually be like a natural phenomenon? Something that's already happening in the universe all around us?
That's a possibility that some of these sources hint at.
Okay.
The chapter on consciousness, for example, suggests that our minds might already be traveling through different timelines when we sleep. And the physics essay speculates that certain extreme cosmic events, like the formation of black holes, could naturally create time loops.
So maybe it's not about inventing time travel, but about discovering it.
Yeah.
Learning to tap into something that's already woven into the fabric of reality.
Exactly. And that's what makes this whole topic so captivating. It's not just about the technology.
Yeah.
It's about expanding our understanding of the universe and our place within it.
Okay. But we can't ignore the elephant in the room paradoxes.
True.
We've talked about the grandfather paradox.
Yeah.
But there are so many other potential pitfalls
Right.
when it comes to messing with time.
Absolutely. And the patent actually addresses this head on.
Okay.
It even proposes a paradox index,
Okay.
a way to measure the risk of creating a paradox
Right.
by traveling to a certain point in time.
So it's like a risk assessment tool for time travelers.
It's exactly. The idea is that by understanding the potential for paradoxes,
Right.
we can try to minimize those risks
Yeah.
or even avoid certain time jumps altogether.
But wouldn't any change to the past, no matter how small, inevitably have ripple effects that could completely alter the present?
That's a fundamental question
Right.
that gets to the heart of how we understand time itself.
Yeah.
Is time like a fixed, unchanging line?
Right.
Or is it more fluid, more like a river that adapts to changes?
Right. If time is a fixed line, then any alteration to the past would seem to create a paradox.
That's the classic conundrum.
Yeah.
But some of these sources suggest that perhaps time is more dynamic.
Okay.
Maybe it's more like a flowing river
Okay.
that can accommodate changes.
Right.
It's possible that even seemingly significant alterations to the past
Yeah.
might eventually be absorbed into the flow of time,
Okay.
leading to a present that's different,
Right.
but not necessarily paradoxical.
That's a bit reassuring, at least from a paradox perspective.
Yeah.
But it also suggests that even if we could go back and change things,
Right.
we might not get the exact outcome we expect.
Precisely. And that brings us back to the question of responsibility.
Yeah.
If we ever do unlock the secrets of time travel,
Right.
we'll need to approach it with a deep understanding of the potential consequences
Right.
and a strong sense of ethical responsibility.
Well, this has been quite a journey.
It has.
We've gone from rethinking gravity to exploring this mind-bending idea of a fractal universe,
Right.
all the way to dissecting a patent for a time machine
It's a lot.
and grappling with like the philosophical and ethical implications of time travel.
It's been a fascinating exploration.
So after all of this, what are your thoughts on time travel?
Mm.
Is it just a science fiction fantasy,
Yeah.
or could it one day become a reality?
I think it's still too early to say, for sure. But what these sources have shown us is that the universe is far more mysterious and complex than we often realize. And while the idea of time travel might seem impossible based on our current understanding of physics, these sources offer a glimpse into a potential future where this is seemingly impossible could become possible.
It's definitely given us all a lot to ponder.
For sure.
What about you? What stands out to you from this deep dive?
You know, I think for me, the most impactful takeaway is that the idea of time travel, as these sources present, is not just about technological advancement.
Right.
It's about a fundamental shift in perspective.
Okay.
It's about embracing the interconnectedness of consciousness.
Yeah.
The fractal nature of reality.
Right.
And the possibility that we hold within us, the potential to explore and interact with time in ways we're only beginning to imagine.
That's a great point. And on that note, we've reached the end of our deep dive into the mysteries of time travel. But the exploration doesn't have to end here.
That's right.
We encourage you to delve into these sources yourself, to ask your own questions.
Absolutely.
And to keep pondering the mysteries of time and the universe.
Keep diving deep.
Thanks for joining us.